Linear regression, derivation. In our first lecture about linear regression, we had explained what is linear regression and also we had gone through all the basics of linear regression. There we had explained that linear regression, this is a method to model the relationship between a dependent variable, we'll call it as y, which is the target, and one or more independent variables, let's say x1, x2, x3 and so on. How do you want to model this? By fitting a linear equation to the observation data. That is, you want to form a linear equation in which using the values of x1, x2 and x3, you should be able to derive the value of y. This is the whole idea of linear regression. Let us say our equation is y is equal to w0 plus w1x1 plus w2x2 plus w3x3. Let us say this is a linear equation. So using this, we should be able to find the value of y. In order to do this, what do you need here? The values of w0, w1, w2 and w3. Once you have the value of these coefficients, you can substitute those values here, and using that, whenever you get a new set of values x1, x2 and x3, you should be able to derive the value of y. This is the whole idea of linear regression. So coming to the derivation, what would you want to derive? That's the first thing. What is our aim if we want to derive the equations for linear regression? What do you want to derive? You want to derive the values of coefficients, that is w0, w1, w2, w3. What are these values is what you want to derive. So in this lecture, we'll be taking the case of univariate linear regression, and in the next lecture, we'll see what is the case of multivariate linear regression. What is univariate? What is univariate? Univariate means you take only one variable here. That is, we won't take multiple variables x1, x2 and x3. Instead, we'll have only one particular variable, which is x1. Once we learn the derivation of univariate linear regression, as a next step in the next lecture, we'll generalize it to the case in which you have multiple variables. Variables means I meant the independent variables. Let us start the derivation. So this is the aim. We want to find w0 and w1 in this equation. I'll write it above and let's start the derivation. Let us say I have the data with me, and the data has the values of x and y. So what is x and y? X is the independent variable, that is what you are observing, and from x you have to find the target variable y. So you have the observation data and in which you already have lot of values of x and y. So if this is the value of x, this is the value of y. If this is the value of x, this is the value of y. So you have a lot of data already with you. The next step is you want to form a linear equation, and in that equation you have to find the values of w0 and w1, which are the coefficients. Why do you want to find this? So that if you are given any new values of x, let's say there is some unseen value of x that you are provided, what is the value of y? This you should be able to derive from a linear regression. This is the whole idea. So let's start. So I already told you y is a target variable. In our equation, we'll use y cap as the predicted value. So y cap is equal to w0 plus w1x. Why am I using y cap? Because I want to differentiate between what is the actually observed target and what is the predicted target. That is, you already have some values of x and y. This is the data that you already have. So for one particular value of x, y you already have with you, but with your linear equation you are predicting some value without seeing the actual y. What is that value? That is y cap. So that I should be able to compare between y cap and y. So the whole idea is this: we'll predict the values of y cap from the value of x. Our idea is that y cap's value should be as close as possible to the value of y. When we are training, we need to be able to compare between what we predicted and what is the actual observed value. So in order to compare this, we'll have y cap as the predicted value and y is the actually observed target value. Okay. So what is the goal that we have? That is to estimate the coefficients. How do you estimate it? By minimizing the error between observed value y and the predicted values of y. That is, between y cap and y, there will be some error. That is, let's say actual value of y is 5 and what you predicted is, let us say, 4.3. So there is an error because actual value was 5 but what you predicted is 4.3. So you have to see this error and you want to find the way to minimize this error as much as possible. That's the whole idea of linear regression. Let us start by deriving the values of W0 and W1, because once you have the values, you can simply substitute. First thing that you want to have is error, because in order to minimize the error, you are doing all these things. So first thing is you want to have the error, then you want to minimize the error such that you have the optimal values of W0 and W1. Okay. So what is the error here? We'll take sum of squares error here. See, you can take any error, but generally we take sum of squares for two reasons. One is that squaring will always make sure that the value is positive. Whatever be the value, be it negative or positive, if you square, it will always be positive. If you have an error in a data, error should always be positive. You should not have negative errors. And secondly, squaring will magnify higher values. If there is let's say a very high error on one particular data, that will be magnified so that such errors would get minimized. This is the whole idea of using sum of squares error. What will be the equation for sum of squares error? You have y and y cap. So sum of squares, you have to sum sigma all the points. Let us say you have n different points. You have n different data points. So you are summing through all the points. Let's say I is equal to 1 to n. What is the squared error? Y minus y cap, right? So yi minus yi cap. So I'm taking each of the observation as ith observation. For ith observation, what is the difference between y, which is the actually observed target, and y cap, which is the predicted target? Okay. This square. So now this becomes sum of squares error, right? This sum of squares error, we have to minimize this such that so that we get the optimal values of W0 and W1. How do you minimize something? In order to minimize, you have to take the derivative, right? The first thing is you have to take the derivative and then equate to 0. This is how you normally find the optimal values. That is, if you want to minimize something, minimize the error, what would you do? You would take the derivative of the error and you would equate to 0. So here we are minimizing in order to find optimal values of W0 and W1. First we will find of W0. So in order to find the optimal values of W0, you have to take the derivative of E with respect to W0, right? And then you have to equate it to 0. This is how you will find the values of W0. Let us do the whole derivation now. I'll erase this and just write the error equation. So my error, sum of squares error, is sigma I is equal to 1 to n yi minus yi cap the whole square. This is my error. If I take the derivative with respect to W0, let's say what will happen. Before that, I'll substitute the value of yi cap. We already discussed that this value yi cap, this is W0 plus W1 xi, right? I'll substitute this here, then it will become sigma I equal to 1 to n yi minus W0 plus W1 xi the whole square. And how can I further simplify this? I can further simplify this as sigma I is equal to 1 to n. I'll open this brackets. So it will become yi minus W0 minus W1 xi the whole square. So this is the error term which I have to minimize. What's the next step? I have to take the derivative and equate it to 0. So this is my E now. If I do dE by dW0, what is the derivative with respect to W0? If I take the derivative of with respect to W0 of this term, first thing is the squared term. From that, the 2 will come outside of this. So 2 times sigma I is equal to 1 to n and yi minus W0 minus W1 xi into what is remaining? Derivative of W0, right? So I'm just simplifying this. So derivative of W0 is, this is minus W0, so derivative will be minus 1. So I'm adding that minus here, okay? So this thing is what I have to equate to 0. It is fine till this point. How do we simplify this? If we divide both sides by minus 2, this will remain as 0. This side minus 2 will go away, okay? If I do further simplification, sigma I is equal to 1 to n. I am opening the brackets. So yi minus sigma I equal to 1 to n W0 minus sigma I equal to 1 to n W1 xi. This is equal to 0. What do I have to find? I have to find W0. So what will I do? I'll take W0 to one side and the remaining terms on the other side, because I want to find the value of W0. So I'll take W0 to one side. Sigma I is equal to 1 to n. W0 is equal to sigma I is equal to 1 to n yi minus sigma I equal to 1 to n W1 into xi, right? So I took W0 to the right side. So that became positive. Sigma I equal to 1 to n W0. Think what is I equal to 1 to n W0. What is this term? You are simply summing up W0 n times. That is W0 plus W0 plus W0 plus W0. You're doing it n times. So it will become n into W0. So instead of this, I'll write n into W0. This is all fine till this point. So let us further simplify this. We have to find the value of W0. So I'm going to take n to the other side. So W0, this will become, this is equal to 1 by n sigma I equal to 1 to n yi minus, again 1 by n will come this side. So W1, this W1 I am going to take outside of summation. So W1 into 1 by n into sigma I is equal to 1 to n xi, right? It is fine till this point. I took this n to the right hand side, so it became 1 by n. So this term will become 1 by n into yi, and the second term will become W1 by n into summation I equal to 1 to n xi, right? So I'm removing this term here. What is 1 by n into I equal to 1 to n yi? This is simply the mean of y's or the average value of y. So I'll denote this as y bar, okay? So y bar is the mean of y, that is 1 by n into sigma I equal to 1 to n yi. This is mean or average value, which I'll denote by y bar, minus W1 into, what is the term on the RHS? The second term, this is 1 by n, sigma I equal to 1 to n xi, which is mean of all values of x, which is x bar. So I'll denote it by x bar. So here remember that y bar is the mean of y's and x bar is the mean of x. So we have the term W0 is equal to y bar minus W1 x bar. So we got the value of W0 in terms of W1. So this is the first part of our derivation. The next part is in which we'll derive the value of W1 without the influence of W0. So using that, you will be able to directly find the value of W1, and then substituting that value here, you can get the value of W0 as well, right? So let us find the value of W1 now. Remember this term, this is the final derived equation for W0. So we have to find the values for two coefficients, W0 and W1. For W0, we've already found it. For W1, let us find it in the next step. So let's start for W1. So again, the steps would remain the same, whatever we had done till this point. So what is our error? Error is equal to sum of squares error, which will be sigma I is equal to 1 to n yi minus yi cap the whole square, right? This is a sum of squares error. Then what did we do? We simplified yi cap. How did we simplify? Sigma I is equal to 1 to n yi minus, instead of yi cap, we wrote w0 plus w1 x, right? This is how we simplified. So it will be xi here because it is the ith term, the whole square. What did we do next? We removed the brackets, right? And then this will become minus. So till this point, it is same as what we did for W0. Now it becomes different. What is different? This time you have to take the derivative with respect to W1 and then you have to equate it to 0. Previously we took the derivative with respect to W0 and then we equated to 0. Here the same case, but we'll take the derivative with respect to W1 and then we'll equate to 0. Okay. So if you take the derivative with respect to W1, what will it become? For this term, I'm taking derivative with respect to W1. So the first thing is this square term 2, it will come to the other side as it came on the previous one as well. Sigma I is equal to 1 to n yi minus W0 minus W1 xi into, now we have to take the derivative of this term minus W1 xi with respect to W1. So if you take the derivative of this term, that is minus W1 xi with respect to W1, you will get minus xi. So I'm putting that minus here, minus xi, okay? Xi I'll add here. So now this term has become minus 2 into sigma I equal to 1 to n xi into yi minus w0 minus w1 xi. This is what you have to equate to 0. Let us solve this now. In order to solve this, the first thing we do is we'll substitute the value of w0, which we already found in the previous derivation. That is, when we derived for w0, we found that w0 is equal to y bar minus w1 x bar. And what is y bar? Y bar is the mean value of y. And what is x bar? X bar is the mean value of x, mean or average. So now you can substitute this w0 here. Then what will it become? A dE by dw1. This will become minus 2 into sigma I is equal to 1 to n. Then this xi term, it will remain as it is, xi into yi minus, what is w0? W0 is y bar minus w1 x bar. This minus w1 xi, right? This is a final term. Once you have this, you have to equate it to 0. So this is how you have to find it. I'm going to erase these terms so that the remaining steps can be written here. So this is what we have now. Derivative with respect to w1 is minus 2 into sigma I equal to 1 to n xi into yi minus y bar minus w1 x bar minus w1 xi. So this is xi, let me write neatly, xi. So we first thing is, if we open this bracket, what will it become? This will become minus y bar and this will become plus w1 x bar, okay? Let us solve for this. So first thing is, as always, this minus 2, this will go away if you divide both the LHS and RHS divided by minus 2. So I'm removing this minus 2. Next step is we have to open the brackets. So if you open the brackets, sigma I is equal to 1 to n xi yi, correct, minus sigma I is equal to 1 to n xi y bar plus sigma I is equal to 1 to n xi w1 x bar minus sigma I is equal to 1 to n xi w1 xi. So that will be w1 into xi square, right? w1 into xi square. So this is the whole term which you have to equate to 0. Next step, what I'll do is, what are we going to derive? We are going to derive value of w1. Because of that, you'll take all the terms which have w1 together and all the terms which don't have w1 together. So if you take all the terms which have w1 together and which don't have w1 together, you can see this term and this term, they don't have w1. So I'll take both of them together. That is, I'll make it under single summation and I'll put a bracket here. This is fine, xi y bar. So I'll write here xi y bar. Okay. So this term came up together, and the terms which have w1, these two terms I'll again group up together. So if I group them up, if the group of this will be sigma I is equal to 1 to n, right? And wi is the term which is out of summation. So I'll take w1. So w1 into sigma I equal to 1 to n. Then what remains in the first term? In the first term, xi bar remains, right? So it will be xi x bar minus here xi square remains. So it will be xi square. So this is what remains from this term. So what will this become for me? Sigma I equal to this particular term I am going to substitute in place of this. Okay. So here I'll be substituting plus, it was minus, right? Oh no, it was plus only. Plus w1 into sigma I is equal to 1 to n xi x bar minus xi square, right? This will be equal to 0. So the next step is we have to take the value which is having w1 to one side and which is not having w1 to the other side. So in order to simplify this, I want a minus here. So what I'll do is I'll reverse these two terms. It will become xi square minus xi x bar, and instead a minus sign will come here. Okay. And these two terms I'll reverse. That is xi square minus xi x bar. The next step is to take this term to the RHS because that is what is having w, and we finally want to find the value of w1. w1 into sigma I is equal to 1 to n xi square minus xi x bar is equal to sigma I is equal to 1 to n xi yi minus xi y bar. So from this you have to find the value of w. How will you find the value of w? You have to take this whole term towards the RHS. Then you can find the value of w1. So the value of w1 is equal to, I'm taking this term to the RHS. So this is the last step of our derivation. Sigma I is equal to 1 to n xi yi minus xi y bar whole divided by this term, right? Sigma I is equal to 1 to n xi square minus xi x bar x bar. So this is the final derivation of W1. So in order to find the coefficient W1, you can substitute the values of x and y in this equation. So you can see here that W1 is not dependent on the value of W0. When we derive the value of W0, what was the value of W0? W0 is equal to y bar minus W1 x bar, right? This is what we derived for W0. So when we found it for W0, we had seen that it was dependent on the value of W1. So you have to substitute the value of W1 in order to find that of W0. But the value of W1 that we got here, it is independent of W0. So in order to find the coefficients, the first thing you have to substitute the values and find the value of W1. And once you find it, you can use that value of W1 along with the values of x and y in order to find W0. So this is the final derivation. You got the values of W0 and W1. What you should do? You should substitute this in the equation. Y cap is equal to W0 plus W1x. Here you have the value of W0 now. You also know the value of W1, which means if you are given any new value for the term x, the independent variable x, from that particular value of x, you can derive the value of y. This is the whole idea of linear regression. So here in linear regression, if you simply substitute these values of W0 and W1, you will be able to find the value for any new target y, provided you have a new data point x. So if you are given the value of x, how do you find the value of y? So this is the whole idea of linear regression. I think it's very clear for you now how to find out the value of a target variable using the technique or the method of linear regression.